Mars, our neighbor planet. Different missions have found minerals like silicon, oxygen and metals on Mars. The planet has a thin atmosphere and its surface is marked from impact craters, valleys, deserts and polar ice caps known from Earth. Mars is the home of the largest volcano and the second highest known mountain named Olympus Mons. Mars has two moons, Phobos and Deimos. Both are small and irregularly shaped, so that favors the theory that they are captured asteroids.
We had the chance to take this amazing panorama. I'm really glad we did. Curiosity is inside Gale Crater, a huge basin made by an impactor about 3.8 billion years ago. The mountains across the crater floor are actually the northern rim of the crater. They rise over a mile above the rover. It's so clear when we took this image that you can even see a hill outside the crater that is 50 miles away. I love how you can see Peace Vallis, a channel that once held a flowing river, like many others that formed lakes inside Gale Crater. This is also the first time we could look back and see everywhere we've been so far in the mission since landing in 2012. Here's the path we took. After landing, we drove to Yellowknife Bay before we turned southwest through Darwin, Cooperstown, and the Kimberley. The rover studied dark, wind-blown sand at Namib Dune. Curiosity then weaved between the Murray Buttes, checked out Ireson Hill, and made a tricky crossing of the Bagnall Dunes before reaching the ridge where it sits today and caught this amazing view.
Today we have a look to the Phoenix mission. The Mars probe Phoenix was launched on August 4, 2007 and landed on May 25, 2008 in the Green Valley of Mars. Phoenix mission was to search for environments suitable for microbial life, to evaluate past or potential planetary habitability in the ice-soil boundary, and to research the history of water on Mars. The multi-agency program was the first mission to Mars led by a public university in NASA history. The lead was directly from the Planetary Laboratory at the University of Arizona, under the direction of NASA's Jet Propulsion Laboratory. The program was a partnership of universities in the US by European states and several space and science institutes. Phoenix marks NASA's 6th successful landing out of 7 attempts on Mars and was the first successful landing in a Martian polar region. Phoenix landed on a flat surface. Just before landing, the craft used its thrusters to orient its solar panels to maximize power generation. The lander waited 15 minutes before opening its solar panels to allow dust to settle. The probe had an improved version of the University of Arizona's panoramic camera, a surface stereo imager, instruments from the ill-fated Mars Polar Lander and Mickael experiment of the cancelled Mars Surveyor 2001 lander. Mickael was a microscopy, electrochemistry and conductivity analyzer. The JPL added a 2.35 meters long robotic arm, a set of wet chemistry laboratories, and optical and atomic force microscopes. The science payload also included a decent imager and a suite of meteorological instruments. The Thermal and Evolved Gas Analyzer, TEGA, is a combination of a high-temperature furnace with a mass spectrometer. Mars Odyssey orbits Mars to transmit the data of the Phoenix lander to Earth. As a relay station, Mars Odyssey receives transmission from Earth and forwards them to the Phoenix lander and the other way around. On May 27, 2008, the first movement of the robotic arm was delayed because the UHF radio system shut off. On the same day, the relay station sent first pictures from Phoenix back to Earth. The robotic arm worked the first time on May 31, 2008. The first panorama pictures from Phoenix arrived on Earth in black and white, showing the head shield and impact site as well as the parachute and back shell. Phoenix made regularly weather analysis and collected probes of dust to find out from what the Mars surface is made of. The Mars surface soil is made of moderately alkaline. TEGA analysis of its first soil sample indicated bound water and CO2. TEGA also detected elements like chloride, bicarbonate, magnesium, sodium, potassium, calcium, and sulfate. On August 1, 2008, NASA announced to have found perchlorate. Laboratory research published in July 2017 demonstrated that when irradiated with a simulated Martian UV flux, perchlorates become bactericidal. Soil samples also released the existence of iron oxides and hydrogen peroxide. Perchlorate is also a potential rocket fuel and a source of oxygen for future missions. A black and white panorama shows the close surroundings of the Phoenix probe on its landing site. The weather created snow falling from cirrus clouds formed at a level in the atmosphere that was around -65°C. Cloud at this level would have to be composed of water ice rather than carbon dioxide ice. On June 19, 2008, NASA announced that dice-sized clumps of bright material had vaporized over the course of 4 days by the robotic arm. This strongly implies that they were composed of water ice. On July 31, 2008, NASA announced that Phoenix confirmed the presence of water ice on Mars. TEGA's mass spectrometer detected water vapor when the sample temperature reached 0°C. Like the Voyager Golden Record, the Phoenix carried a Phoenix DVD within. The disc was designed to withstand the Martian environment for at least hundreds of years. On November 10, Phoenix Mission Control reported the loss of contact with the Phoenix lander. Images of the relay station showed that the solar panels of Phoenix were irretrievably damaged by freezing during the Martian winter. The final message of Phoenix sent to Earth was Triumph in binary code. The microscope showed that the soil on the top of the polygons is composed of flat particles and rounded particles. Unlike some other places visited on Mars with landers, nearly all the rocks near Phoenix are small. While Phoenix life ended, the analysis of data from the instruments is in its early stages.